H1 link active scheduler PID piping instrumentation diagram loop scheduled and unscheduled communication, that is LAS. This one LAS link active scheduler. Here will come LAS SIM FIM4. Here also STT35FFS FF5 5, and then this one STT35FF1 backup LAS. The STT35FF1, STT35FF3, STT35FF6 all are link active scheduler. Last link active scheduler PID loop scheduled and unscheduled communication. Function blocks. In these function blocks, here up to this, here analog input 110 PID, up to here 110 PID. Pipeline instrumentation diagram. Analog output. This is analog input. Here analog output. From here to here, loop 110 period execution. Scheduled closed loop control. Unexpected. Unscheduled. Alarms, events, maintenance, diagnostic information, program invocation, permissives, interlocks, display information, trend information, configuration, functional block execution, scheduled communication, unscheduled communication. That is here this color function block execution. Here this one, this one, this one, this one, this one, this one. Scheduled communication. This full scheduled communication. Scheduled communication. And then unscheduled communication. Remaining they start with unscheduled communication. Under this, up to here, analog input. This is functional blocks. Analog input, PID, and then here analog output. Loop 100 period execution. 110 period execution. Link schedule. In this link schedule, controller builder R210 under FTEP scheduler for link 1501 macro cycle 1000 project. Here root ACE R210 FTEP R210 C220 C10 FIM link 0301 link 0302 R210 FIM demo link 1501 and 1502 SIM C200 underscore R210 unassigned. Here control builder R210 FTEP this one schedule for link 1501 motor macro cycle 1000 project. Here R FF loop, here R210 FTEP link for link 1501 macro cycle 1000 into project. Okay. Here FF loop FF underscore loop underscore 1 AI dot AI. So here FF loop 2, here loop 3, loop 4, loop 5, and so on. This point, green is execution, red propagation, yellow agent. Here, 0, 125, 250, 375 up to 1000 ms. Okay. Total distance or scheduled activities 1138 27. Time used by applications 27.60. The block convert operation has completed. Macro cycle usage gain mark 68.19. Latency improvement factor LIF 38.63. Publication gas availability improvement PGI 983.96%. High speed Ethernet HSE over high speed Ethernet over FF integrated architecture. FF integrated field architecture HSE subsystem integration. High performance control backbone, standard Ethernet equipment and wiring, standard functional blocks plus flexible function blocks for discrete batch PLC, redundant HSC interfaces and devices, linking devices LD integrated H1. HSC provides the operation open interface for data services. Here MIS application packages, data servers, high speed control and integration backbone. Okay. Here communication, here communication. Then from LD, here communication. High speed control and integration backbone, HSC. High speed control and integration backbone. High speed Ethernet devices. High speed Ethernet devices. 100 megabits switch. HSC client. HSC field device. 100 Mbps switch. MFX per switch. Linking device. Plant H1. Linking device. Gateway. IO network. Inside MIO inside HSC LAN redundancy. HSC client, this is router HSC client, HSC field device, gateway, IO network, field device, the linking device, plant, H1, IO network. These are HSC device redundancy. HSC device redundancy. High speed Ethernet. HSC client. Here HSC field device. Router. Gateway, linking device, IO network. H1, all are Fieldbus. Plant. Okay. Additional points. Foundation Fieldbus is tried and tested since 15 years. Only FF supports temporary master like handheld or laptop. 8 channel temperature transmitters replace 8 regular transmitters. Fieldbus electric actuators eliminate 6 to 12 pair of wires. Only field FF supports firmware upgrade instead of circuit replacement. FFR provides a closed loop digital control sensor to actuator. Fieldbus provides flexibility to add devices to the bus. Fieldbus provides flexibility to use additional signals in the device. Fieldbus eliminates proprietary MOV bus. No need to change I/O card type when device type is changed. FF integrates gas chromatograph in assist management software. Fieldbus is made easy thanks to users and EDDL, etc. Fieldbus is not really one thing but more of collection of things. Fieldbus is a group of protocols that are used in industrial area. The Fieldbus protocols have been standardized as IEC 61158. Allen, for example, here ControlNet Profibus connected to Allen Bradley. Fieldbus network topologies, ring topologies, branch topologies, star topologies, daisy chain topologies, like this, star, branch, ring. Programmable logic controller, Ethernet switch connected. Fieldbus is not a connection type, but instead description usually indicate a group of protocols. There are several protocols in the group such as ControlNet in the Allen Bradley family, Modbus, Profibus, Ether, CAT, HOT, CIP, and many more. Fieldbus, ControlNet, Modbus, Profibus, Ether, CAT, HOT. Here, ControlNet, Profibus, I/O data distribution, I/O data block, field distribution device, and connected to Allen Bradley PLC. Here, Profibus, Profihub, ControlNet connected to direct Allen Bradley PLC. Then C1 PLC is there. From Profihub, C1 PLC. From Profihub, Schneider PLC. Profib is direct connected to Profihub. From Profihub, it is connected to Allen Bradley C1 PLC, Schneider LT. From ControlNet, direct Allen Bradley connected. ControlNet is an example that cannot integrate into Siemens processor. Here not able to connect. Here Schneider not able to connect. Some protocol would not play well with the others. ControlNet is an example that cannot integrate with the Siemens processor. Here ControlNet, Profibus, ControlNet connected to Allen Bradley. This one ControlNet if you connected to Siemens PC, if you show error, Profibus only will connect. This is information. As you can see, there should be great care taken when designing your plant management, including communication network and especially the device layer if considering field-based devices. Here, as you can imagine, your controller system will need to have communications. Module that will be able to establish communication with the field devices. In the case of ControlNet, you need to ControlNet module Profibus would be need Profibus module. This is not say that every protocol is dedicated to a particular manufacturer and must connect to the proprietary controller. For instance, Profibus is widely used protocol that can be connect Allen